Hello, everyone, and welcome. I'm Dave Russell, owner of Dave Russell Media based in Northwest Ohio. It is my pleasure to moderate today's webinar, Fine-Tune Your Water System for Summer and Fall Disease Challenges. Today's webinar is brought to you by Pharmgate Animal Health and Farm Journal. And thanks to you for joining us. Now, before we get started, let me remind you that at any time during the webinar, you can ask a question by using the question mark icon at the right of the screen. Now, if you are not seeing that question mark icon, you are probably viewing in full screen mode. Just hit the escape key to see the icon. Well, the purpose of today's webinar is to help you choose the right method of treatment for your swine herd when it comes to responding to a disease challenge. This webinar will focus on water medications, including how they work compared to other methods. Joining me on the webinar is Chad Smith. Chad is a veterinarian with Pharmgate Animal Health based in Goldsboro, North Carolina. Dr. Smith has spent the first 15 years of his career as a staff veterinarian for Maxwell Foods. In his current role on the Pharmgate Animal Health Technical Services team, he collaborates with leading veterinarians on product field trials as well as provides technical support to production veterinarians and managers. Also joining us, Jesse McCoy. Jesse is Neogen Corporation's Business Unit Specialist for Water Treatment, where he develops and implements water treatment chemicals and programs to aid in production animal health for poultry, swine, and ruminants. An environmental scientist, Jesse has extensive experience working with large integrated production agriculture companies as well as independent producers. Jesse is also a certified water specialist from the Water Quality Assurance Program. Chad, Jesse, welcome to the webinar. I'll turn the program over to you.
Thank you, Dave. Pleasure to be here, and I'd like to welcome all our viewers or listeners this afternoon. The topic is to fine-tune your water system for summer and fall disease challenges. It's a perfect time of year to look at your water system as they're being taxed very heavily during this summer, this heat wave we're experiencing. We want to focus on antibiotics and water-soluble delivery methods, but we're going to review all the different routes of administration for antibiotics because water-solubles are not the only ones out there and they're not appropriate for every case. And so we want to look at the decision criteria that will lead you to choosing water-soluble medications, the advantages of water-soluble may have over other administration routes, and the best practices to ensure that you're getting the most out of our water medications. And in order to do that, we're going to take a deep dive into our water delivery systems. And it's important to remember that water-soluble antibiotics require a fully functional and adequately designed water delivery system. And water plays a big role in antibiotic delivery anyway, and we're going to focus on the solubility of some of these medications and the effect that pH will have. So first, I'd like to review the different routes of administration for antibiotics. There's water-soluble, feed, and other oral, injectable, and topical. And by far, the water-soluble, feed, and injectable are used most commonly. So how do we make the decision between which form we administer these medications? First off is the availability. Not all antibiotics are available in all forms. Next is what are the antibiotics labeled for? So we've got to look and see, especially with feed, we have no ability to administer feed medications other than what the label prescribes. Working with your veterinarian, there is extra label use of water and injectable medications. Often that is not possible due to some restrictions. So we've got to pay attention to the label claim on the antibiotic. And then at the farm level, what we see is often the decision comes down to how many animals do I need to treat today. If it's just a few, 3 or 4 animals, we may try an injectable method. But if it becomes the whole barn or group of animals where we or trying to medicate thousands of animals, then water-soluble becomes a very desirable application method. Finally, the last thing we consider may be the animal's health status. Often these animals are sick and stressed, and additional stress of administering an antibiotic is not desirable. So here what we'd like to present is some of the common drug classes for swine and their current label claims. And so you'll see the drug class, the drug names, and then what pathogens they're labeled for in that administration form. So injectable, water-soluble, or feed. And the biggest thing I want to take home here is that while a certain product may be labeled for one pathogen in the injectable, it may be labeled for totally different pathogens in water-soluble or feed. And so we've got to have an understanding of what the product is labeled for. And then the other obvious thing to notice is that not all antibiotics are available in all forms. And so that may limit our ability to apply that particular drug. So as we've talked, a lot of times at the farm level, the decision to go to water-soluble medication is based on the number of pigs and the health status of those pigs. The advantages of a water-soluble delivery is that it's low stress for pigs and people. There's no chasing pigs around. Once the medications are mixed up and through the water system, we're done with the administration process. It's reduced time and labor, and that all we've got to do is mix up the medication at the point of application. We do not have to go through and individually administer to every animal. It's fast and flexible. We don't have to wait for feed order systems, delivery to the farm, managing feed already in the delivery system at the farm level. And pigs continue to drink as appetite drops. So as a pig experiences disease and the clinical manifestations of disease, we'll see that first thing to go will be their appetite. And then as they continue to get sick, they will at least continue to drink water for a time period. So water-soluble delivery offers that benefit of the pigs are still drinking water. It's safe for people and pigs. We don't have to worry about inadvertent needle sticks or broken needles, so it's safe for people, pigs, and poor. And then it's efficacious, it works, and that leads to judicious use of antibiotics. Here I'd like to remind everybody, as Dave mentioned, to submit their questions. We'd like to have some good feedback from this presentation, and now we'll turn it over to Jesse.
Chad, thank you for the introduction to this. So I'm going to take over here and talk about how water is affecting our water-soluble antibiotics and what we can do to improve their use. So it's important to understand that when we're dealing with a water-soluble antibiotic, we want it to be soluble. And that means we want it to dissolve the entire way. If we don't get it to dissolve the entire way, you've got those parts and pieces of that drug still in the bottom of the bucket, you're not going to get all of the drug into the water line. So solubility is the key as we go on and continue to talk about applying water-soluble antibiotics correctly, that we're actually creating a solution and we're not creating a concentrate or an emulsification. So we have to get it to dissolve. And we have often thought about solubility being related to pH, the pH of the water it's going into, the pH of the stock bucket that we're creating is important to the solubility. And we've also talked about other minerals that can have an effect, whether it's high iron or high manganese or calcium, all of these different aspects of your starting water quality that can affect the ability of that drug to go into solution. So really, are we creating a suspension instead of solution? And when we're talking about solubles, we really want a solution, not a suspension. So again, we want to be able to see through that bucket. We want to see the bottom of the stock bucket. We don't want to see any pieces or chunks of anything left floating in there. To that end, this is a chart created by Dr. Stephen Clark, who I respect and admire very much, of relative pHs of water-administered medications. Basically, when you mix these different antibiotics into water, does the pH go up, stay the same, or go down? And the thought has always been that we need to match the water pH with the relative pH of that drug to ensure complete solubility, to the point where we would make recommendations of lowering pH with citric acid or raising pH with baking soda to try to help that water pH match the relative pH of the antibiotic. However, what we know now, and I very much believe this because I did the research, is that the pH and the minerals are not affecting our stock solutions. So I want to say that again to make sure that everybody hears it correctly that's out there. Your starting water quality is not affecting whether your drug that you're applying goes into solution or not. So you no longer need to worry about, did I adjust the water quality to match this drug anymore? The drugs are going to be soluble in your water no matter what. However, I'm sure there are many of you out there thinking, but we can't get this drug to mix, or we can't get that drug to mix. The issue is not your water quality. The issue is either the drug itself will not mix in that much water because you're running the high dose, or you're trying to put more than one drug into this stock solution. So as long as you're running the labeled dose in your water by itself in the stock bucket, it will dissolve. Now, that might mean you need to stir it more than you're used to. That might mean you need to use room temperature water instead of cold water. You might need to create that stock bucket a little bit early. But as long as you are mixing one drug into that bucket, you are not going to have a solubility issue. So the issue, going back to dosage, right? We don't have enough water. So we want to make sure we're using the correct amount of water, that you are actually using 5 gallons instead of 4.5 or whatever. And there are some meds that at some rates will never go into water. So you want to talk to your veterinarian about, what do you do at that point, right? If I can't get this to go into solution, what do I need to do? And that needs to be a discussion that you have with your veterinarian to make sure you're doing the best thing that you can, and having judicious use of those antibiotics. But another big thing we see once we create a solution inside of the water line, and this happens to be my favorite picture ever, is what if we don't have a clean system to apply it through? Okay, what happens when we're running a drug in a water line that looks like this? And before you think this is a picture that we have just magically created for this, this is from a swine facility. This was their supply line. And the problem they were having is not getting the drug to the pigs. And the issue here is that line is full of E. coli, and that drug doesn't care where it comes in contact with that E. coli. So it was never getting to the animal. So we want to talk about cleaning water lines to make sure we have a clean supply line going to those pigs. So why do you want to do it? Are you removing all your dissolved or suspended solids? Volume reduction, pathogen loading, increasing the efficacy because they're making it all the way to the pig. Getting that uniform dose, right? If you've got dirty lines at the end of a water line versus clean lines up front because all the debris goes to the end of the water line, then your pigs up front are going to get a good dose. Your pigs at the back are going to struggle. And then, the first drink that pig gets is the worst drink it gets when you put it inside that barn. So we want to clean that line out in between turns to make sure that your pigs have the best water possible when they come into that barn. A volume reduction, you'll see right here the edge of the penny to Lincoln's head. A 3/4 inch water line, which is what most people are running, will carry 5.5 gallons of water per minute at 40 psi. If we have just that much buildup on the inside of the line, and I think as you're listening to this, you're thinking maybe I have that much buildup, you're going to lose about 30% of the water volume per minute you can get to those pigs, which means you're going to lose 30% not only of the water that you can get into them, but if you're running a water-soluble antibiotic, you're going to lose 30% of the antibiotic that you can get into that pig too. So your pig's turn, their health turn on getting better is going to be slowed down because they're going to have to go back to that water line to get the full dose. So when we're talking about cleaning water lines, you know, everybody out there sells a chemical. We sell 3, right, on what you can use. So you've got to make a decision. Do you want to clean? Do you want to disinfect? Do you want to descale? What buildup do you have? And then you want to use a different technology than you're using currently if you're doing water treatment. If you're not, then you know you've got a bunch of different options. And what we're really talking about here is biofilm or bioslime. So this is now a buzzword in our industry. People are talking about it a lot. The definition of biofilm is the mechanical resistance of pathogens to disinfection. And what that really means in practical terms is a coral reef, okay? You've got this biology that sticks to the inside of the water line. It pulls minerals out of the water. It builds itself a nice home. And then once it gets too big, it goes and colonizes something else. It's the exact same thing a coral reef does inside of the ocean. The difference being it takes years for a coral reef to build itself into the size that we see. Inside a drinker water line in a swine facility, we're talking about 2 days to colonize an entire line. And this is what it looks like under an electron microscope. You can see all those cracks and crevices where the biology can hide from the disinfectants. And this is what it looks like from a practical standpoint. You see the 2 different colors inside of those water lines. That's where the biology has selected which minerals it's going to build a home out of and then built the biofilm in those locations. So hopefully I've convinced you that it makes sense to use a water line cleaner, especially if you're going to apply a water-soluble antibiotic. Now the question becomes, what do I clean it with? So the typical chemistries that we see, I'm going to list on the screen. You can read them. I don't need to read them all for you. But these are all different chemistries that have water line cleaning claims. But in reality, this is what works. So silver stabilized peroxide, perquats, and bromine chlorides. And as a rule, they work at 3%. It's important to note, however, that waterline cleaning is an EPA registered claim. So the waterline cleaner that you use needs to have an EPA registration number on it. And normally when I give this in front of people instead of virtually like we're doing today, I have a number of people in the audience that will raise their hand and say, the EPA doesn't enforce that rule. And I'm here to tell you that they do. This is the docket number of a FIFRA infraction from 2014. It happened in the Midwest, and you'll see disposition payment received. And that means someone got fined for using a non-registered waterline cleaner. And it's important to point out that they had a section in there for the labeling that it was mislabeled, that the person who distributes or sells it, and that there's a civil penalty for this infraction. And the EPA docket itself, you're welcome to go look it up. The 2 things that were pointed out were waterline cleaner and removing biofilm. So if you have a line cleaner that says it's going to clean the line where it's going to remove biofilm, it needs to be registered for that use. And if not, you are subject to an EPA infraction. So now that I've gotten off my soapbox about EPA registrations, the question becomes, how do you get higher concentrations, right? How do you get 3%? You can use sump pumps by creating a stock bucket. So 48.5 gallons of water, a gallon and a half of your cleaner, now you've got 3%. Mixing stations, that's the black Venturi on the right. It's just like what's inside of your power washer right now that you bring soap in with. You hook it up where your medicator goes, put the right tip in there. On that one, it's the yellow tip, and it'll draw 3%. And there is one adjustable proportioner that will do 1 to 128 to 3% if you want to use proportioner, but we all call them medicators. But what's not on that list? And it's your standard 1 to 128 medicator. A 1 to 128 medicator is 0.78% dilution. So if you hooked 3 of them up together, they would work. But if you're planning on doing line cleaning with a medicator, it needs to be the 3% model, not a 1 to 128 model. It will not work. Until now, there is one product on the market that is labeled for waterline cleaning and disinfection, compatible with on-farm medicators, and puts the correct amount of chemistry in there. That product is called Parasite 15. It's on the screen right now. It's the only EPA-approved 15% peracetic acid waterline cleaner in the animal production market. It cleans and descales, it disinfects. It's compliant with your medicators that are there. It's not a new process for your producers to do, or if you are a producer, it's you take the lid off the jug, you drop the tube from your medicator in it, you turn it on and fill your water lines, let them sit overnight, and then you flush them out the next morning. And typically people right now say, it'll clog my drinkers if I try to clean my water lines. And my response to that is always, clog them with what? If you're worried about cleaning your water lines and clogging them, then you've already admitted to yourself you have buildup inside of your water line. You know that you have buildup inside of your water line. Let's go ahead and choose the chemistry that will clean them out and not clog your drinkers. So when we look at that, here is a Perquat. This is peracetic acid, and this is silver stabilized peroxide. I really like peracetic acid. That's why we've developed the waterline cleaner that we have, because while it may come out of your drinkers looking like chocolate milk or the worst sweet tea you've ever had in your life, it will still come out of the drinkers, and you don't have all the extra labor of having to take the nipples out and clean screens and all that. So how do you do it? You use the right amount, and you do the little things. You trigger the drinkers, okay? I tell most people to take a broom handle and walk down the aisles, trigger the drinkers so you don't have to go over any gates or anything like that. But that water system is from the well to the mouth of the animal. So you need to get that cleaner from the well to the mouth of the animal. And then flush it with treated water, right? You've got that buildup inside of there because there's some type of contamination, whether it's biological or it's mineral. You want to use treated water to flush it because then you're going to keep that growth to a minimum as they come back in. But I think the real takeaway message is use the product that suits the situation. So read the label or call your distributor or your manufacturer that has these products and ask them how to do it, and then apply it correctly with the correct equipment.
Well, again, thanks to Pharmgate Animal Health for bringing us this information. You can ask questions throughout the presentation by using the question icon at the right of your screen. Questions will be answered at the end of the webinar. Chad, we'll turn the program back to you.
Thank you, Dave. I'd like to build upon what Jesse brought up earlier and some of the physical factors we see affecting water medication delivery. And the first is mixing protocols. We want to use a clean bucket or a bucket liner. Jesse showed a great picture of a E. coli infected water line, but we see the same thing with the buckets we use to mix our stock solution. We don't want to have to medicate our medication bucket, so use a clean bucket or bucket liner and follow the instructions for product mixing. One of the common areas we see concern, especially in discussing solubility, is the amount of water, but the time to stir as well. There's quite a bit of confusion out there about the difference between the solubility of a product and the rate at which it dissolves, or the dissolution rate. And so we've got to stir it long enough for the product to go into solution. And then, as mentioned earlier, water temperature also plays a role. You won't see that being a huge problem on the farm, but it will play a role in how fast the product will dissolve. And so it could confuse people who are mixing it up, that maybe the products, they consider the product not being soluble when all they have to do is use a little bit warmer water. Be careful though, because some products will tell you to use cool water. You can get some cloudiness in the stock solution, which may confuse farm employees as well. So be sure to follow the label instructions when mixing. The other thing is our water systems. They need to be fully functional, and they need to be designed for the size animal we're dealing with. So here's the water requirements we got for various phases of growth in pig and the required flow rates. All of our water medications make the assumption that pigs are able to drink the appropriate amount pretty much as they like. It's important to remember though that these pigs are in group housing. So we're not talking about what an individual pig wants to drink, but we're talking about the social dynamics of pigs and how they drink. So pigs are not going to want to stand at a water access point, a water nipple or a cup, if the flow rate is inadequate. They're not going to want to stand long enough to get as much water to drink as they would like. And the same goes with the number of water nipples or number of access points. You can see in this chart that how many pigs are recommended per nipple water in the height. And this is, again, to make it easy for the pig to access water and make it comfortable so that they'll drink as much as they desire. And so here I'd like to thank you for your participation in today and to summarize what we've gone over so far. The decision criteria for using water-soluble medications really depends on if that particular antibiotic is available in a water-soluble form and the label claim on the product. So does it labeled to treat the pathogens we're after? At the farm level, we will see that the number of animals we're trying to treat will influence our decision. And as the number of animals increase, water-soluble becomes a much better option. And then the pig's health status or the disease challenge will influence that as well. The benefits of water-soluble is it's low stress and there's less time and labor to administer, and it's fast and it's flexible. So remember to follow the label mixing protocols or the SOPs for your system. And remember that we need a water system that is designed to handle the number and size pigs that are at your site. All of our water medications are designed to be administered to a pig that's able to access and drink as much water as they desire.
And another thing important to remember is that the water quality itself is not going to be what determines the solubility of these drugs, but the water quality and the solids inside of that line is going to determine how well they get to your pig. So it's important not only to clean those lines ahead of time, but choose the right water line cleaner to make sure that it gets done in the proper way.
Dr. Smith, Jesse, thank you so much for providing us with some really good information here in this webinar today.
Well, Dave, thank you so much for having us on. I really appreciate the opportunity.
Yes, thank you so much.
Well, we do have some questions, but before we get to those, let me remind those listening in that if you have a question, just use the question mark icon at the right of the screen. And let me mention too that if we run out of time and don't get to your questions today, it will be answered by email within the next week. Gentlemen, if you are ready, we have some questions coming in. And the first one, I switched from one antibiotic to another, and my new antibiotic isn't dissolving. What's the difference?
I think from a water quality standpoint, my first question would be, did you clean your stock bucket out when you switched those two antibiotics? One thing that I see often in the field is either not using a bucket liner or using a dirty bucket will cause the next antibiotic in there, if there's some residual antibiotic, to actually have an interaction with the new molecule. But if you're using the same type of antibiotic and one is dissolving, quote unquote, and the other is not, then I would look at spending some more time stirring or something along those lines.
Well, again, we're getting some really good questions coming in. Another one that deals with kind of the same thing, Jesse. I used an antibiotic in water and it plugged up the drinking nipples. What went wrong?
I wish that I never got this question again. I often hear, and it depends on what the plugging is, okay? If that plugging comes from white or brown, what I'm going to refer to as snotty substance, and sorry to everybody out there that hasn't run into this, and everybody that has is shaking their head saying, yes, I know exactly what you're talking about. That is a fungus that we find that feeds on carbon. And so that is something that we see from dirty water lines, from not cleaning water lines out ahead of time. And that is the one thing that I can tell you, that if you see that every time you run an antibiotic or any water soluble product, that it's very important for your location, and it is geographically based. There's nothing you can do about having it. I'm sorry ahead of time. It is going to be paramount that you clean those lines prior to running anything. And when you are done, you run fresh water or water line cleaner again through there to get those spores out.
Again, a reminder, if you have a question today, you can use the question mark icon at the right of the screen. Another question in, what can I add to water to make medications dissolve better?
So I think in this, we come back to the question is whether or not it is actually soluble, or the time that we're allowing for it to dissolve. And so the first thing I would recommend would be to just stir it for longer, or maybe we need to look at the label and make sure we're using enough water to dissolve the product. Some of these medications, we reach saturation, and most people don't really understand saturation in their stock solution, but most pig producers understand saturation when we're talking about humidity, especially this time of year. As we get these real humid days, we can move as much air through a building as we want. It's still going to feel muggy and wet. And that's because air is saturated with water. It's very humid. We see the same thing in these stock solutions. If we're not using enough water to dissolve the product, we can actually reach a point where the water is saturated with the product. And so it will look like it's not soluble, when in fact we just need to add more water and stir it longer.
Well, Chad, Jesse, your presentation today has certainly got folks to think. Another question, how do I choose a line cleaner that won't interfere with my antibiotics and or plug the water nipples?
So I think this is probably a twofold answer. And I'm going to answer part of it, and I'm going to pass the other part to Chad, because he's a veterinarian and I'm not. So choosing your water line cleaner, first and foremost, you need to make sure it has an EPA registration number on it. And it is very easy for me to tell you, because you're a pig producer, the best line cleaning chemistry that you can use is peracetic acid. So any peracetic acid based water line cleaner with a registration would be my recommendation. Because we're talking about running a product with an antibiotic, I would pass it off to Chad and say, Chad, do you know of any antibiotics that have a claim to run at the same time as water administered treatment?
No, I do not know of any antibiotics. Generally, what we try to do is we try to make sure that the lines are clean prior to administration of the antibiotic. And then we want to clean the lines after we've used any water-soluble medications. And this is to prevent any residuals in the water line. And so we'll run that after, but currently I'm not aware of any that are labeled for concurrent use.
And I can't think of any water treatment chemistries that would be labeled for use with antibiotics. So I think the answer is you run them before and after, but you do not run those two things together.
Well, again, if you have a question, just use the question mark icon at the right of the screen. So, gentlemen, when is the best time to flush a system after cleaning?
So if you're cleaning, I recommend that we clean water lines between each turn. Just as if you're doing, wash down on the walls, you're cleaning the floors, you're cleaning out all the feeders. The one thing that most people don't touch as part of their normal cleaning and disinfection program is the inside of the water line. So I'm always going to recommend that you do water line cleaning in between turns. And then, as Chad just alluded to previously, cleaning before or after your antibiotic, just to make sure you've got a clean line to run it through would be my recommendation.
Chad, I think this question might be for you. How do I know that all the pigs are getting the right dosage of water-soluble medications?
Unfortunately, that's part of treating a population of animals and relying on them to drink. You've actually got to go out and inspect that the animals are up and drinking. And if you see individual animals that are not drinking, then those animals will have to be dealt with on an individual basis. But by and large, animals have to be very sick before they go completely off water. And so the water-soluble route is a great tool for treating large groups, large numbers of pigs, but it still takes individual animal inspection.
So is there a point where you would recommend switching from spot treating with injectables to mass treating with water?
That's where you're going to have to look at the individual situation and work with the herd veterinarian and understand the limitations within the system as far as labor and administration and then training of the employees. It's not something that you can just throw out a hard number and say at this point go to water solubles. You've got to understand that the goal is to get the pigs treated, and what we're dealing with is in the real world scenario is what do we have available to ensure that's done appropriately and effectively. And so water solubles we'll see as the number starts to overwhelm what we can manage on an individual basis, or the pigs we just don't want to get in and physically stress the animals trying to administer an injectable. Water soluble becomes a great tool at that point.
Well, we are getting close on time, but again, let me remind everyone that if we run out of time and don't get to a question that you submitted, it will be answered by email within the next week. What do you consider the most important factor when deciding whether to treat with water, feed, or injectables?
Well, the most important factor, again, is going to be the number of animals that we need to medicate, what tools we have at our access to get that done, and whether there's an available form of the desired medication. So do we have the form that we want to administer? Do we have a product in that form that can be used?
All right. Well, our next question, we have always been told to add citric acid when preparing our stock solution for CTC, OTC, tetracycline. Based on Jesse's comments on water quality, should we be doing this? Chad?
Yeah, well, this is a very common practice. We see it routinely, like you mentioned with Penchlor and some of the other products. Generally, it's not required. And I say that because pH modifiers are usually included as part of the carriers in a product. And they're cover most situations. The only exceptions I'd see would be some pretty extreme water conditions, or if we're trying to create a super saturated solution. We do see acidifiers affect dissolution rate. And I keep bringing that up because it's important to remember that part of the mechanics of administering water-soluble meds is a person actually mixing up the medication and stirring the stock solution. And so they're going to be very interested in the rate of the dissolution, or how quickly it dissolves. I generally think of acidifiers as being a convenience. It gives us a peace of mind that, our medication is going into solution, but it's generally not going to impact the delivery of the medication to the pigs.
Okay. Jesse, do you have anything to add?
No, I think Chad hit it on the head, right? It's not going to affect the solubility, but it may affect how fast it goes into solution.
All right. Again, let me remind folks, if you have a question, just use the question mark icon at the right of the screen. Another question we have in, can water lines be cleaned with pigs in the barn?
I'll take this one if it's okay with you. The answer is yes, but. Okay, so yes, water lines can be cleaned while pigs are in the barn, but you need to make sure you've got a product registered for that process. I can tell you that at Neogen, we have taken the time to get the proper registrations, and Chad and I have actually talked about this before. We may be the only water line cleaners out there that have an EPA registration, both for pigs in the barn and pigs out of the barn. What you need to remember is you need to look at that label and figure out what rate to use while pigs are in the barn, and it's going to be lower than you would use while pigs are not in the barn. That may mean that you need to run it, let's say 2 days in a row instead of one time. We've had customers out there that run it 2 or 3 times. My recommendation for people, if they want to clean lines while pigs are in the barn, is to do it overnight. So the last chore of the day, you get your stock solution set up, because it's going to take a stock solution to do it. Get that set up so that as it's drawn into the barn with the pigs, it will last until the morning. You want to make sure that chemical is there the whole time so that you get the most effectiveness out of it and the time. And then the first chore the next day, you want to flush those lines out. What's happening is overnight, you're breaking down those pieces of material and contamination that are inside of that line. You want to try to get as much of that out without the pigs drinking them as possible. And so the next day, first thing, shower in or change your boots going through your Danish entry, and then flush those main trunk lines out and trigger those drinkers to just get anything that would be suspended in that line out. But the short answer is yes, but you need to make sure you use a properly registered product, and it'll say it on the label.
All right, very good. Well, Chad, Jesse, I can't believe it, but we have already run out of time. Now, let me again mention, for those of you that did not get your question answered today, it will be answered by email within the next week. Let me thank once again Dr. Chad Smith, veterinarian with Pharmgate Animal Health, and Jesse McCoy, business unit specialist for water treatment with Neogen Corporation. Again, our thanks to Pharmgate Animal Health and Farm Journal for their support in bringing this webinar to you, and thanks to you for joining us. Just a reminder that this webinar will be available online at porkbusiness.com. Now, if you're watching then and a question does come up, you can use that question mark icon and your question will be answered via email. So again, that is at porkbusiness.com. Thanks, everyone. Have a great day. I'm Dave Russell.